Now that we have implemented a single functional React component that is super basic, we will expand on it in the upcoming screencasts and make it more complex. But before we do that, this is a really good place to stop and focus on the DOM. Now, if you've gone through the HTML screencast, you'll understand that the DOM is the document object model within the browser, and it is a tree-based structure that represents the visual components of what we see in the browser. In other words, it's a very tree-based representation of the hierarchy of everything that we see visually inside of the browser. Now, this DOM is extremely awesome and extremely useful, and it's really important for how the browser functions in that it is used for rendering what the user sees on the screen. When we created our functional component, we did see that we had our application functional component, and then inside of it we rendered a child component called a to-do item display. Now, before we get any more complex in our to-do item display, it's really good for us to understand how React utilizes the DOM. And one of the cool features of React, in order to make sure that we don't slow down the user's browser to where it is unuseful or very frustrating for the user to use, we use a functionality called the virtual DOM. And that's what we're going to explain in this video right now, is the virtual DOM. Now, a good resource to understand the virtual DOM is this blog post right here, programmingwithmosh.com, React Virtual DOM Explained. And he does a really good job of explaining the DOM. So after this video, if you still don't quite get it after I explain it, make sure you go read this blog post by Mosh. He does a really good job, so I would suggest reading that after this video. So let's talk about the DOM. And we're going to do that, of course, by drawing on our blackboard here. All right, so inside of our browser, the browser itself is what handles rendering the contents we see on the screen. So we're going to go ahead and create a box here, and we are going to label that box as our browser. And we're going to see how this all works. We've got a browser, and inside that browser, we have the visual part of the browser, and that is what we actually see. So this is going to be the visual display. And this will have inside of it everything rendered that we can visually see inside of the browser. Now the browser, when it goes through and it parses our HTML documents that we send to it, it creates in the background in JavaScript a virtual DOM. And we actually refer to it as the DOM itself. And so the DOM sits right here, and it is a direct structural representation of the visual display, or what is being displayed on our screen. So we'll call this the DOM, which is the document object model of what we see inside our browser. Now, this document object model, we have the ability to access it through JavaScript. And we access it a lot when we use JavaScript when we are building our front-end applications. So we've got our visual display, and then we've got the DOM, which backs up this visual display. Now, in our document object model, I mentioned that it is a tree hierarchy or a tree structure. And that is because if we look at HTML, so if we jump over here to our document right here, we have our HTML tag, which is the root of all HTML documents. We have our head, which contains metadata for our document. And then the other sibling element inside of our HTML document is the body. And the body is what we're most worried about when we talk about the DOM. Let's go ahead and open up our drawing again. So in our DOM, we're really focusing on the body. Now, the entire document object model is in there, but I'm going to bypass the HTML root element, and I'm going to bypass the head element, and we're going to focus just on the body right here. Now, when we say that it is the model of what we see visually, what we're talking about is that it is a hierarchical tree structure that we then render in a visual hierarchy with a visual format, and that visual hierarchy can be adjusted using CSS, and we talked about that when we talked about HTML and CSS. So let's go ahead and let's draw out the visual hierarchy that we would have from our body component. So from our body right here, so this will be the body, and then under the body, if we're following our current React component, in that body we have a div, and that div sat underneath the body, and that div was the root div. And then inside of that root div, we then had our app component. So we'll put our app component right here. And then under that app component, we then had our to-do item display component. And it sits right here in this hierarchy. And the hierarchy goes from parent to child. So we've got a parent component that houses, so if the body, it houses that root div, and then that div houses our app, and then the app houses our to-do item. So let's go ahead and tag those so we know what we're talking about here. This one is going to be the body of the HTML document. And then this one is going to be that div that had the class of root. And then we had our app component. And that is our React app component. Its HTML is then there. And then we have our to-do item display component. And that again is a React component. So we've kind of got this hierarchy here. And then visually, if we were to lay this out visually in our DOM, we would then have it look something like this. And instead of these objects in a tree structure, we would have boxes that are nested. And let's follow that right here. So our body would take up the entire browser window. And then we have this div class root. And since it's really the only one we have in there, it's probably going to take up the entire body because we don't have any other divs that are siblings to it. Then we have our app component. So it's going to be right here. And then our to-do item display component lives inside of that component. So this tree structure we have right here ends up becoming nested boxes or nested elements inside of our HTML display. So this is the DOM and this is the visual display. And now we're going to get into the fact that updating this DOM, this hierarchy, can become extremely slow if we have a lot of updates to it within a short amount of time, and then we require the browser to continually redraw all of these nested boxes based on this hierarchy. So if this hierarchy right here became more complex, so let's go ahead and build a more complex hierarchy. Use the circles right here. If we have a parent HTML element right here, and then it has a child element, and maybe it has a couple of children elements. Let's go ahead and put those in here. And then each of those then also have their own child components or child HTML, child elements. Just make sure we use the right terminology, child elements. And we're worried about rendering all of this up here in the display. Let's go ahead and show how this works. We've got a parent, goes to a child, goes to a child, goes to a child, and goes to a child. And then this one has its own children. And as this tree becomes deeper, in other words, we get deeper into the hierarchy of parent-child components, and then we begin to have grandparents and great-grandparent components. As this becomes more complex, the amount of time it takes to render visually in our browser becomes more complex. Because if we take this hierarchy right here, where we have a parent element and then sub-elements, we're going to end up with a whole lot more boxes with a whole lot more boxes inside of those boxes and then inside of those boxes. And it becomes more costly to render our HTML document. Now, each time the document is modified by JavaScript, so each time a new element is added to our document, our DOM is re-rendered by the browser. Okay, so every time we add something, we get a re-render of the browser window. And as this becomes super complex, those renders get slower and slower. Now, enter React. When we add React to the whole mix, okay, and we begin to add React components. So I'm going to outline perhaps this one as a React component. Oops, we want our squares is what we want. Let's go ahead and outline this one as a React component with its child components, and this one as a React component with its child components or elements. Now, when React adds or enters into this situation, and we're making our user interface extremely dynamic, meaning that the HTML inside of these components changes very quickly as the user does things to them. If we didn't handle the redrawing of the DOM in an effective way, then as the user makes changes to these components inside of the DOM, each time they make a change, this page has to be redrawn, and it has to be redrawn pretty dang quickly in order to keep up with the changes. Now that makes sense. Anytime a user changes the HTML, like they click into an input field, so maybe this is an input field right here, and they click into it and start typing, we want to see that text show up inside of our display so we can see that we're actually typing. If it didn't do the redraws, we wouldn't see the text as we're typing it inside of this input element. And that would be very disconcerting for the user. So the redraws, and especially the redraws when we are typing inside of input boxes, is extremely important. And we want to see those immediately in order to not confuse the user. But as our React components become more complex, the changes to our component, especially when we are modifying the HTML within our component, when we do those changes, if we had to redraw the entire hierarchy, the entire HTML structure, and we had to do it for every single change that was made inside of a component during its life cycle, we could end up with a queue of a lot of redraws that need to happen. And then let's say that we have a whole bunch of modifications to this HTML that happens, and then the user clicks inside of this input and starts typing. Well, if the DOM is behind in its redraws because we've done a whole lot of changes to the HTML in this component and it hasn't caught up yet, and then the user clicks in this input and begins typing, we will actually see a pretty good delay in the typing as the user types, which would be disconcerting and would cause the user to question what's going on. And so these redraws that can pile up as we modify a React component can begin to really slow down the user's perception of what's happening in the browser. And we want our applications to be super snappy, and we don't want the user to feel a lag or a slowdown or any kind of delay when they try to do something in the browser. Now, if we rely just on the browser's implementation of the DOM, every time we make modifications, a redraw is going to be requested, and it's going to try to keep up with redrawing. And as we make more and more changes to these components, maybe one or more component, maybe as we type in this one, we're adding new stuff to this component, and we're trying to visually change the way this component looks, we're going to have a lot of redraw requests happening, and it's going to bog down the browser. So the way we fix that is React introduces the virtual DOM. And so right over here in JavaScript, inside of React, we take an exact copy of the DOM, or React does. It takes an exact copy of the DOM and it copies it down here into the virtual DOM. So let's go ahead and label this as our virtual DOM. Now that we have an exact copy of our DOM over here in the virtual DOM, and I'm not going to redraw all of this just to save time, with an exact copy of the virtual DOM in JavaScript in memory, and it just mimics what's in here, as we go through the life cycle of a component, and as we are quickly changing stuff inside of this component or inside of this component or multiple components across our application, and we begin to modify the DOM, instead of modifying the browser's DOM and getting a backlog of redraws that need to happen, instead, React likes to use batching. And what batching is it stores up a bunch of those changes as they happen inside of the virtual DOM, which means now instead of changing our actual browser DOM, what's going to happen is as we make changes to our components, these changes are going to be recorded in the virtual DOM. So each time an element changes between renderings of our display, or between the lifecycle methods of a component, those changes are going to be recorded inside of the virtual DOM. And then when we have a good point, in other words, the majority of these changes have happened, or the lifecycle events, the update or whatever inside of this component has completed, and all of the changes have been done to the document, and React has decided it is a good time to redraw the screen, what will happen is that React will take its virtual DOM and it will then make a comparison between it and the actual browser's DOM. So it will do a comparison between the two, and it will look to see what are the differences now that all of these changes have been made. What are the differences between the virtual DOM and the actual DOM? And it looks to see what the differences are. And some of these changes down here may have happened and then they were overridden by other changes. And instead of having a redraw for those changes that were overwritten by other changes, we wait until we hit a good point and all of those changes and overrides and overwrites from other components and other changes to the HTML have completed. Now when we do this comparison, instead of all of these changes being pushed into the browser's DOM, instead only the changes that matter at the time that we do a redraw, only those changes will be reflected or modified inside of the DOM. So if we want to illustrate that, all of these changes right here will happen for a certain amount of time, and then some of those changes may no longer be important because they were overridden by another change. So some of those are going to be not needed anymore, or they're not going to be important anymore. So let's kind of say that this one right here, it was good, but then it got overwritten by this change here. And let's say that this change right here, it was good during the time that the virtual DOM was being modified, but after all these other changes, that change was no longer current. It was no longer needed because let's say that this change right here overwrote or undid that change. Let's say that the same thing happened with this change and with this change, because these three changes actually, through the time span, undid or overwrote these changes. And so then when the DOM is ready to actually execute a change to the actual browser DOM, so when React is ready to make a change from the virtual DOM to the actual DOM so that it will be written to the display, what will happen is it will then take the current state of changes, which based on this, these were the only changes that were still relevant after everything had been changed using the React component and the React lifecycle. So we really only have 3 changes instead of 1, 2, 3, 4, 5, 6, 7. So instead of 7 changes at this point in time, only 3 of the changes are relevant, and only those 3 changes need to be communicated to our browser DOM. And so then these changes are then going to be pushed up into this DOM after the comparison is made, and it will see that we really only need to change this element, actually, where does this one go? This element, and this element, and all the other changes that had happened during that time span were no longer necessary. And so we really only have 3 changes and 1 redraw that happens in our visual display instead of these 7 changes all requesting individual display updates, because we would have been modifying the browser's DOM directly. And if each of these had been pointed to the DOM, we would have had a backlog of redraws for all 7 of these. Now, of course, I'm talking small number of changes, and those would be imperceptible in a browser. But if we were making hundreds or thousands of changes to the DOM because we're using a really complex React app, you could see how all of those redraws could pile up and create a very slow and sluggish browser. But by using a virtual DOM to capture all of the changes over a particular time period, and then doing a comparison between the actual DOM and the virtual DOM, and only capturing the changes that are still relevant, we can actually drastically reduce the amount of redraws that need to happen in the browser. And that is what our virtual DOM is for. And that is why React has a virtual DOM, and it is why it does everything in a batching mentality, is because we don't want to have a redraw for every single change that React makes to the user interface. We would like to have only batches of changes done, and only those changes that are still current or relevant should be in that batch. And then once we make a comparison between the current state of the DOM and the virtual state of the DOM, then React will only make those changes that are still relevant to the actual DOM, and then a redraw request will happen in the browser. Now, this is a super brief overview of the virtual DOM, the browser DOM, and the browser display, and the concepts that are used in React in order to make sure that React is extremely dynamic and allows us to do a lot to change our user interface dynamically, but at the same time only allowing changes to happen once they are relevant and still current without negatively impacting the performance of the browser, and therefore making sure our applications stay super responsive when the users are using them.